Welcome everyone, and hello. Good morning from the brewery here in London. My name is Patrick Fischer, and today I'm going to talk about going serverless with AWS Lambda using platform events. So this is a session part of the Advanced Developer track. So if you're less experienced with development, you can also attend, and I will try to explain everything in a bit more detail. A bit about myself. So my name is Patrick Fischer, as I said, and I work for Collaborative Group, a platinum partner here in London. I work in a technical architect capacity. I've got about 4 years of experience in the Salesforce ecosystem and following sort of the architect track in the architect program, hopefully towards CTA fairly soon. So why I'm presenting about this specific topic is because I'm very interested actually in building scalable solutions on Salesforce, really building system integrations, integrating with other systems such as AWS and Lambda, what we're going to talk about today. So specifically then, first of all, going serverless. What the heck is going serverless? We're going to touch about a few reasons of why you should probably consider going serverless, and especially with AWS. We're then also going to look at some serverless solutions and architectures in the Salesforce ecosystem and how that could work. I'm going to provide some samples and then also demo one of the examples as well. Then I've obviously come across some challenges, and so that you don't actually have to spend all the hours again that I already spent, I'm going to share all the lessons learned out of the challenges that I've faced going serverless. I'm going to also touch on Salesforce Evergreen, which is a serverless approach that Salesforce is currently pushing quite a lot. And then hopefully we have some time for Q&A later. So first of all, what the heck is serverless? Well, so some of the challenges that I want to touch on, and here are my top four challenges that I see a lot of companies facing today. So one of them is that you actually spend a lot of time provisioning and scaling up and down and managing servers. So traditionally, when building a web application, you would usually spend significant time and effort managing servers, scaling them up, and have actually an infrastructure and DevOps team to manage these, especially to handle high requests and high volumes. Now, one of the solutions going serverless is actually to run them run those as events available on servers that are just available at that point in time, and all these servers are managed by the vendor. They're actually not managed by yourself or your DevOps team. One of the second approaches to going serverless is actually you usually pay 24/7 full-time for actually your server, even for the time that is not utilized. So one of the reasons for going serverless is actually you would only pay for the time when these events and when your serverless function actually executes. You wouldn't be billed, or you wouldn't need to pay for any of the time that is not utilized. Then third main reason that I see is now with serverless functions, code is usually hosted on a provider. You would upload it once and then it's executed whenever it's requested. So actually, if you think about a global application that you access globally or worldwide, you might actually experience high latencies if you only have a server located in sort of one location. You could also spread out across a few locations. But actually, with going serverless, you can really run those functions wherever is closest to your actually end users. So you actually reduce latencies for your serverless processing. And I think the main fourth reason that I see is that a lot of web applications and a lot of systems right now use usually a single sort of backend language. But sometimes you would actually want to use more than one programming language for the reason that you want to access maybe certain other extensions to the programming language or certain other packages and executables that are only available in certain programming languages. So with serverless functions, you can have different languages for different functions, which is quite nice. So your web app might be written with Node.js or Go, but then for other functionality, you want to use maybe Java or Python or a different programming language. As a next step, I think we should probably think about a bit of a definition of what serverless is. So actually, serverless is a computing model that lets you run applications without having to worry about managing and scaling servers. Nevertheless, serverless still uses its underlying server. So there's still the computing under the hood takes place on servers. You just don't have to deal with these servers, so that's the main advantage. So there are quite a few use cases that are all sort of running on demand, and they don't have to constantly run. So what I see, if we have multimedia processing, like image recognition, or if we have big IoT devices pushing a lot of events into maybe a stream, then these events, they come not statically, they will come whenever they are requested. So the function needs to execute ad hoc. So some of the other examples might also be web applications, APIs that are requested ad hoc, and there are lots of use cases for actually going serverless and executing functions whenever you need them. So how do these functions then actually run? Well, before we get started here, I think let's take a closer look at how serverless and Lambda or serverless functions generally work and the architecture that we're going to set up. So before code can execute, you want to make sure that all of this is actually uploaded or added to your provider, for instance, AWS. And then actually whenever it's requested, the provider will find the code that is required to execute, and it will then spin up something called a container to actually run that code just for a specific execution. And it then can also scale up and down. So we'll spin up a container for every single request or every single event that needs to be processed. So as an example, when an API requests a Lambda function or is firing a Lambda function, then that would spin up a container that would do its processing and then potentially call back or respond with whatever response is required. Lastly, then all containers after the execution are going to be decommissioned after the task, so it's not required anymore. And then only the organization is only charged for the time that actually the function runs. And usually that's sort of measured in milliseconds, usually 100 milliseconds at a time. So let's think about Salesforce then. We just touched around serverless in general. So in Salesforce specifically, why would we want to go serverless? Right, here are some of the examples. So typically, you want to work around limits. You often face limits in Salesforce, especially when you talk about processing high volumes of data and highly complex data. Examples could be CPQ pricing, field service lightning routing, voice and image recognition. You really want to think about where you process that, because doing all of this on platform, on Salesforce, you might actually run into limits or CPU timeouts and other limits. Think about your data storage limitation. Think about where you want to store your data, especially with large data volumes when you have millions of rows. And potentially you want to export that data or actually extract that into another data store outside of Salesforce. Regarding file storage limitations, so we all know that the file storage on the platform itself is fairly limited, and especially when you generate a lot of PDF files or other files, you might want to think about off-platform solutions. Similarly, you also potentially want to think about it when you use Conga or other packages. Conga, for instance, does all the processing also off-platform and not on the platform, and it's being processed ad hoc. When we talk about integrations and integrating Salesforce to other systems, we often use REST and SOAP APIs. But what do we do if there are maybe other systems that use different protocols, maybe FTP, that is being dropped with a CSV file? We really have to pick that file up and process that file ad hoc whenever that's dropped. So potentially, Lambda function could run and then call back into Salesforce whenever that's being placed or changed. Similarly, when database rows are actually changing. And then my favorite point really is using external languages and external libraries. So support for multi-programming languages. Think about Salesforce. You have your Apex backend, you have your JavaScript front end. But what do you want to do if you want to use maybe Java library and Node.js library or some other libraries, potentially for machine learning, image and audio processing, translation services, and there are so many more examples out there. So you really want to think about functions that could use different programming languages to execute that logic. And then regarding event queuing and streaming, there are lots of IoT examples out there where we really have to process lots of events, millions and billions of events per day or even per hour. So if you think about enterprise level streaming, then we might not actually think about platform events or even IoT cloud. We want to think about maybe a more scalable solution that can actually run that processing off there. So that being said, serverless computing has quite a few forms, and one of the forms is function as a service. Function as a service is being implemented by quite a few different providers, and I've already touched on AWS, which is Amazon Web Services that offer the Lambda functions. Lambda functions are fairly quick, and you can actually spin them up whenever a certain event is being fired. It's being usually metered by a number of requests and the memory allocated to that request and how many milliseconds is actually being executed. A typical way to measure different providers and compare them is actually by comparing it by gigabyte per second memory processing. So that's a typical way of how you want to compare them, and you actually see, surprisingly, that Lambda is actually one of the more expensive ones compared to Google Cloud Functions or Azure. Nevertheless, Lambda has quite a good free tier, so anything you probably want to do with up to 1 million functions is most likely going to be free for you. Salesforce is also going to be a provider very soon. They've announced at Dreamforce or around Dreamforce that they are going to push Evergreen functions, which are right now in the closed developer preview, so you can, I believe, still sign up for it. It will take a while to get approved though, and you will need to have a good reason. We're going to touch on Evergreen in a second. However, there's still a few limits and costs unknown for Evergreen. So for today and for this talk, I'm going to focus on AWS as a provider. So let's think about a solution of how Salesforce can integrate with AWS. So firstly, you obviously have the Salesforce platform, and with the Salesforce platform, we obviously know that we can create event buses being platform events. So platform events, I'm going to show that in my demo in a second, are events that are being created on Salesforce, and you can publish events and subscribe to events. And you can publish to them using, for instance, process builders, flows, API and Apex, and even change data capture is also some sort of event bus that you can actually subscribe to. So different options, either platform events and automation or change data capture to actually fire an event. Then as a next step, we would want to consider that somebody actually subscribe to that event bus. And with AWS being involved here, we will need AWS to subscribe to it. Now, it's unfortunately not that easy to just fire a Lambda function directly off a platform event. So we're going to have a bit of an architecture in the middle there to interface that. So AWS Lambda is going to run and actually subscribe to the event bus continuously. Now, one of the challenges is that AWS Lambda only runs up to 15 minutes. That's a challenge, because after 15 minutes it will close down. That's the maximum. So what we can do is, using AWS CloudWatch, we can actually fire AWS Lambda to run every 15 minutes again and again, to resubscribe and therefore be continuously subscribed to the platform events. That's being done via commit D. And then whenever an event is coming in, i.e. when a process builder publishes an event, it will go via Lambda, being the subscriber, into another event bus. And in this case, in this example, I'm using AWS SNS, Simple Notification Service, which is similar to the platform event bus on the platform of Salesforce. And then that's where, in my opinion, the real serverless processing starts, because we have an event being added to a message queue, and we can then subscribe to it using further Lambda functions, and we can really process and do whatever we want to do. So, for instance, my demo today is going to talk about some machine learning feature using AWS Comprehend. But there are also lots of other options of what you want to do. You could potentially use AWS Lambda to run some further translation services or any other features that are either on the AWS platform or further off platform away from AWS. So every time an event is being published into the event bus, that's going to trigger down and fire an AWS Lambda function that runs serverless. So these functions, again, could be multi-programming languages. They could do further callouts to external systems and connect to other AWS services. They can also then call back into Salesforce, potentially using the REST API. There are lots of libraries out there. If you have a Node.js app running on Lambda, that will call back using, for instance, Enforce, which is a library to call back into Salesforce. So just to point out, the real serverless piece is really the bottom part whenever you've pushed an event to an SNS. Now, one of the challenges that you might be facing is how many platform events you actually have available with your org by default. Usually around 50K are coming with a typical org allocation, and you can then subscribe to them, as we discussed earlier. Now, this solution here is a different approach to doing the same thing, but it doesn't use platform events, which might be slightly more scalable, which I will explain in a second. So in this approach, we could actually fire off something called an invocable method, which is an Apex method on Salesforce that we can fire from configuration. So once set up the invocable method, by the way, you can find all of this on GitHub as well. Once you find the invocable method, that will push through directly to AWS. And that could be done using just a web service callout and could directly push to SNS. Previously, we said we would have, in solution 1, a subscriber that runs continuously, basically 24/7 to subscribe to it. In this approach, it will directly push ad hoc, meaning it does a RESTful callout, for instance, directly into SNS. We could put AWS API Gateway in front of that to actually provision that as an endpoint.
Another approach is that there's a GitHub community-based AWS SDK, so not official one, that you can actually directly post as well into Amazon SNS and publish an event. That is fairly scalable because every time the platform, potentially the process builder runs, it fires the invocable method and publishes the event into SNS. And from then onwards, nothing different to what we have discussed with you before. So you just fire your Lambda functions, you can call back into Salesforce, do whatever you want to do, and that is running serverless from down there. Again, to summarize why you may want to consider solution 2 over solution 1 is because solution 2 here doesn't use platform events, which follows limitations and quite a few limitations on the platform. I'm now going to jump into a bit of a demo where I'm actually going to touch on these individual items based on solution 1 that we've just touched on. So jumping right in there, if we jump into Salesforce and we go potentially to a lead, in our example we want to maybe identify that a lead record changes, or we actually create a lead and we then want some logic to run. To do that, we create a platform event, for instance, which I call the Lambda event, which has a number of attributes, potentially a message that could take any payload, potentially the record ID to easily access the record ID and process that and then call back. And so on and so forth. We could also use change data capture instead. In this case, we used the platform event, and whenever there's a new or changed description field, we would actually fire a message using platform events, using the description field from the lead. So the description, if that's going to change, that goes fire off to AWS. We're also going to have to provision a connected app, just to then later on call back into Salesforce using the processing that has been completed off-platform using the serverless function. In the next step, we actually then need to create an account on AWS. And once we have an account, we navigate to the SNS, the simple notification service, to create an SNS queue. I've done that already, so mine is called SFTC events. So all the events that are going to push through from Salesforce are going to later on end up in the SFTC events message queue. Slight technical issue. As a next step, we would then actually have a Lambda function that would continuously subscribe to that notification queue. So that Lambda function is going to subscribe to the platform event and then push into the notification service. So for instance, using CloudWatch events, we said we'd fire off the same Lambda function subscribe every 15 minutes. This here is my Lambda function, and you can also access all the code directly on GitHub. I'm going to share the link after. We're going to use the client ID and client secret here to actually subscribe to Salesforce and subscribe to the individual message event bus. And then we're also going to forward all the events that are going to some Salesforce, forward them onwards into SNS. So we're going to publish them into SNS and moving them forward. As a next step, we can also extract some of the dependencies. So I said I want to use Enforce, one of the libraries, external libraries available for Salesforce, which I moved into a layer. So an AWS layer is to actually store your dependencies. One of the next steps is you also want to consider some of the individual environment variables. So for instance, any reusable components or configuration, you can easily change in environment variables in Salesforce. And similarly, the execution role is something that's managed by AWS service to actually specify that you've got access to SNS. So you need to make sure that you've got access to the individual notification service to actually publish to it. That's a one-time setup as well. Inside the CloudWatch on AWS, we're going to publish that function every 15 minutes. We're going to run that function every 15 minutes. So we set up that trigger to run every 15 minutes, and that's going to send out and fire off the Salesforce committee subscriber function. In the next step, we would then publish it to the notification service, and that notification service will then actually forward that event into the actual execution of the Lambda function. The execution Lambda function, in my example, would be an AWS Comprehend feature. So AWS Comprehend is a way to actually run some machine learning and understand what the text that you input into Comprehend is actually doing. What language is it? So some of the features is that you can identify key phrases as well in Comprehend. You can identify the sentiment of the individual text. You can identify people, places, locations, and lots of things that are actually part of the text under the hood. Similarly, you can also detect just what language is it. So I'm going to have a test here with different languages and going to show you how that actually executes. We run all of this, again, inside the Lambda function, which is actually then running serverless. And whenever something has been processed, we're going to call it back into Salesforce using the enforce library. That being said, let's jump into Salesforce. So inside Salesforce, we would now, let's create a lead, right? I create my name, and I'm going to add some description, because the description field is the field that's actually going to fire the call out by using platform events into AWS. So let's say, okay, I'm here today, calling in from the brewery in London, and well, I love AWS and serverless functions. So that's what I'm going to put in, and then I'm going to save my lead. I've added a component under the hood that whenever a callback happens, the page automatically refreshes. So the callback happens, and that's when the serverless function has already executed. What we can see is AWS called back and identified, okay, this is English, this sentiment is fairly positive, and also we've identified different entities here. So there's a person, it's Patrick, there's a location, the brewery, and also London, UK. So we can identify that, and there are actually so many use cases, you can analyze the different text in your description. Now, one of the benefits of being a German native speaker is actually to try a German test. So let's try a different language here. So as an example, you might have got a case that potentially says, oh, there was a very bad service here to our customers, and I can't really recommend John Wayne. So if I fire that off, the page refreshes, and let's see what AWS tells me about that. Well, the language is German. The sentiment, well, it was a horrible customer service, therefore the sentiment is negative. And we'll identify a person. So we could directly link that potentially back to our users or our service advisors and so on, our service reps. There are a lot of use cases out there to actually run Comprehend out of Salesforce, but I mean, this is just one example, and there are lots of other services on AWS that we can't directly use from Salesforce right now. So this is a machine learning library, and I can really recommend looking into that, and you can find all the code on GitHub as well. So to summarize, a record has changed on Salesforce. We fire an event into the event bus. That's going to be republished into SNS. And then we ran the middle approach, which is AWS Lambda to use AWS Comprehend. And that's where the serverless processing is happening and then calling back. All right, awesome. So that was the demo. I hope you enjoyed that bit. One of the next pieces I want to discuss are some of the challenges that I faced. So one thing I already highlighted is with Lambda, if you have long-running transactions or long-running executions, you may not be able to use Lambda properly, because Lambda only runs to a maximum of 15 minutes. So after 15 minutes, those methods and functions will actually close down and time out. So to rerun that, I had to use AWS CloudWatch to refire the Lambda function. As a next step, it's best practice to move all your dependencies into a Lambda layer. So if you have dependencies such as the enforce library, I've created a Lambda layer and uploaded that on GitHub too, so you can directly import that. So all for instance, packages such as enforce, AWS SDK, and other SDKs, just put them into a layer, and that is more reusable. You also want to store your credentials, as explained, into Lambda environment variables. So Lambda environment variables allow you then to easily deploy and go live and just switch around the environment variables whenever you push it from a development environment potentially to production or other test environments. Similarly, learn about AWS roles and policies. It might be a little bit confusing to people who have never used it, at least to me it was. So a policy to me is really a set of a few permissions that you really want to set up, and that is potentially a permission called Comprehend full access, which is a permission to run AWS Comprehend. Whilst a role uses a number of policies, therefore a role is more like a Salesforce profile or a Salesforce permission set. So a role uses a number of policies to actually provision a function. So a Lambda function runs with a specific role, one single role. Similarly, consider Salesforce limits. Consider platform events, how many you have available, how many you can fire. If you want to fire millions of platform events from Salesforce, expect that there will be a limit and you will hit a limit in the 24-hour period. Calling back, calling back into Salesforce is the inbound REST calls that you also have limits around a few 100,000 depending on how many users you have in your org. And then outbound calls are, let's say, free. There are not really any limits on how many outbound calls you can make from Salesforce. That's why I have also proposed solution 2, which doesn't use platform events and just based on outbound calls. And then also lastly, consider AWS costs. So if you use Lambda and continuously subscribe, it will be more expensive because it runs 24/7. And similarly, if you use API Gateway, that has quite a bit of cost as a baseline. But anyway, the AWS feature has a free tier, and usually everything I played around with was free, so I didn't have to pay for anything. So it will be free for you too. The last bit I want to touch on today is going to be Salesforce Evergreen. And Salesforce Evergreen is an offering that is similar to what AWS offers with Lambda. It's a new feature first blogged about during Dreamforce last year, and then now in developer preview, but it's a closed preview. So what is Evergreen? Well, with Evergreen, you will have two programming languages available. You will have Java and Node available, and you'll be able to fire those serverless functions directly out of Salesforce using process builders, using Flow, using Apex and other ways to fire automation, and then run that serverless function. And that processing will all happening on the platform. So as opposed to running it on AWS and needing to have a middleman like the SNS queue, you actually will be running it on the platform, so it will be easier to configure and easier to set up. However, that being said, you probably want to consider your limits, which are not yet determined. You also want to consider the cost. I'm assuming it might be more expensive than AWS Lambda on its own. And then also, there are lots of other use cases as well, potentially to access external data stores as well, potentially a PostgreSQL database. So that being said, thank you very much for tuning in and today to attending here as well. I've put together a list of useful resources as well, including my code that I've got published online. So there are quite some good GitHub repositories that I can recommend here. And similarly, there are some good tutorials out there around Salesforce Evergreen, so I can recommend accessing those. So yeah, thank you very much. Now we've got some time for the Q&A session. So if you've got any questions, I'm not able to see them directly, but feel free to post them into the YouTube channel. If there are any questions, please feel free to read them out. Yeah.
Just 1 second.
Oh, just getting a microphone. Right, so I think what you typically have is teams that are experienced building in Java or any other backend languages, for instance in Node.js or Go or something like that, which would be typical languages. I often see teams that come from a web development background that actually have the AWS skills but not the Salesforce skills. So as obviously Salesforce is using Apex on the backend, if you have an Apex skills, then it's very similar to Java, as we all know. So I think when you have Apex skills, you can easily build out your functions in Java. I think if you've got front-end skills, JavaScript skills, you can easily build out your functions in Node.js. So I think these are transferable, and therefore you can't use the exact same language, but I believe if you've got some experience building out in Salesforce, you'll be able to manage that. And again, all the steps to just set it up, that's part of my presentation. They're also online in a step-by-step guide, so you can find it there. And yeah, let me know, reach out if you've got any detailed questions on those. Right. Yeah, so thank you very much for attending, and yeah, let me know online if you have any questions.